Hello, welcome to Brown Dog Gadgets Live. I'm Amanda, the Education Outreach Coordinator here at Brown Dog Gadgets.
I'm the other
We've
guy.
got Pete with us again today. Yay.
I'm here again. Why not?
Yeah.
There we go. Adjusting the levels.
Today we are going to be jumping back into MicroBit University. But before that, if you have not followed us on our social media platforms, please do so. You can find us on Facebook, Instagram, Twitter, or X, and YouTube. Also, the guides for the project that you see today, as well as all of our other products and projects, you can find at browndoggadgets.com. If you have any questions, especially about the code, or if Pete's just not making sense, please drop in a question or a comment in the chat. Or if you think you have a better way to do it, let's see what you got.
You got some cool beans.
Yeah. Otherwise, you can always email us afterwards at help@browndoggadgets.com.
You got it.
We also are still accepting applicants for the Pathfinder Summer Institute, our Circuitry and Robotics with Lego and MicroBit workshop. It is a 30 to 40 hour workshop. We are together on Zoom. It is free for U.S. public and charter educators and librarians. And all you have to do is sign up here. And then we send you a big old kit worth of $500 or more worth of stuff, and we teach you how to use it. Join us. It's not a joke. It's not a joke. It's free.
You can use that one for anything.
I guess so.
Okay.
All right, we're going to switch to MicroBit time.
Hey, overhead works today.
All right.
Great.
So today we are doing the LED matrix again, which
Yeah.
we did last time. But this time we're using the LED matrix with a push button. And then I believe we're doing, it's counting, right? Each time we press the button.
Yes.
All right,
I
so
should
let's see if I can
should really get a front-facing camera. I'm going to add one
prop
for
it.
next week.
Here, I'll just hold it. It'll be fine.
That'll work for now.
Yeah. Perfect. So for guide A,
Yeah.
I press the button
Press the button.
and it counts up.
As long as you
Yay.
press it nice and slow.
Okay, I'm taking my time here.
So when you get to 9, it'll
And then it goes back to
roll
0.
back over to 0.
But
Okay.
if I go too fast, that's too much for its brain.
Right.
All right, Pete, tell us about this code.
Okay, let me push the right button here. Hey, there I am. I look sickly. I don't have any lights. Okay.
Whatever.
I'm the one who's not sickly in the office, right?
Right.
Let me get rid of that pop.
Same.
Okay, yeah, as we saw, this is really simple. You're just connecting a single button. Let's look at the code. So this is probably like the kind of the simplest version of the code. Now, I think we talked about this before. Oh, try to hold the button down. So if you hold it down, it's gonna count up every. Do you want to guess? The delay between the counting up. Do you want
Nope.
to guess? Yeah, I don't want to either. Because
Great.
that's-
Then why are you trying to
Because-
ask me, Pete?
That's it. We don't have any delay in our code. It's basically the microbit is running as fast as it can while using the built-in LED matrix. Now the cool thing is it's really nice to have that LED matrix on the microbit. It's built in, it's easy to use, but there is a cost for using it, and that is speed. So you can see like how fast that's going. It takes, if you hold it down, like that's as fast as it's gonna go.
Got it.
And if you look at our code, again, it's the same stuff we've been doing. This time we're turning on the LEDs. We set up pull pin to pin 5, and then over in the forever, we're going to check when that pin gets pulled to ground, which happens when you press it, and it's going to change the value, and then it's just going to check real quick, hey, if it's more than 9, greater than 9, set it to 0. So we won't roll over to 10. You can display double or more digits, but it scrolls on that screen, so it's even slower that way. So basically, we're going to check for that button press, and we're going to show the value. Now, as you can see, it doesn't go super fast.
No.
When we get to the, and microcontrollers run pretty fast. I mean, they are pretty darn quick. It's just running that matrix slows it down. Like when we connect in probably a month or so, when we connect the 7-segment display, which is the external.
Or more, because we have Pathfinders in there too. July, maybe?
End of the summer. But when we connect that, you'll see that number just blazing fast, like you won't even, just burns through it. So yeah, this is what we're doing with so as you noticed, if you keep pressing it quickly, it won't catch those presses because it's still like running the code it needs to display the matrix. So, but again,
and you connected the button to 5, so I can also press A.
Yeah. So if you wanted to do like, a counter like we've done here, it'll work as long as you don't need to count things very fast. If you're counting laps and it takes a good 5, 10, 20 seconds to do a lap, no problem. If you're counting some other thing that happens in less than a few seconds,
claps,
you're running into a few issues. So that is the code for that one. And then we basically, some of this code is not going to be, I'll say like, oh, this is the way to do it. What we're basically doing is exploring different ways to write code and do things. So the next two are going to be similar, a little more complex, and we try to deal with a few different things. So,
all right. So B looks pretty much the same, except for when I hold it on my end.
Right.
So same idea. Starts at 0. I press. It counts.
Yep.
I hold.
If you hold
doesn't
it down
until
now,
I release.
Here's a question for you. Does it change when you press or when you release?
When I release, because I can tell that when I'm holding.
Yeah. So let's look at that one. Yeah, and if you get to 9, it'll roll over.
Yep.
So again, everything's the same here, slightly different code, which we will look at here.
Well, and I think that's the great part of using this MicroBit University to teach coding, is that we're giving so many different ways to do these small parts that it's just giving them so many more tools in their toolbox.
Yeah, definitely. And within the make code interface with the blocks, I think you can really gain a familiarity with sort of, from when we go from one thing to another, it doesn't look completely different. It's not a wall of text that's confusing. So.
Right.
Okay, so this time we are doing a little more, and I feel like we did use fairly similar code to this in our earlier button exploration with the LEDs. But this time what we're doing is we're setting a value based on reading that pin. And we're also setting the previous value to check if it's changed or not. And then we have an on state, and again, our value. So the first thing we're going to do is we're going to set that button value to reading the button. Is it a 0 or is it a 1? Is it high or is it low? And then we're going to check if the previous button value is not equal to it, which means it's changed state. So over here in the start, we've set them to the same when it starts up, when the MicroBit gets power. So then we're going to say, hey, if that button value equals 0, or if you've pressed the button, we're going to set the button value to whatever that is, if it's 0 or 1. And then we're going to check the on state, if it's 0 or, if it's 0, we're going to do this. We're going to change our value. We're going to increment the value. Check if it's greater than 9 and set it to 0. Otherwise, down here, we're going to show it. And then once again, we're going to set that previous value to the existing value. So the next time around the loop, they're the same. And then we're looking for that change between them. So it should function pretty similar to how the previous one does. Slightly different code to deal with it. And yeah, if you press and hold, it shouldn't go forward because it's got to look for that
until you release.
Yeah, right. Yeah, so that is that code. Hopefully that makes sense there.
Awesome.
Yeah. Let's go to the third one.
Yeah, then we've got letter C.
Letter C.
Oh, version 3. Letter C, version 3.
Yeah.
Okay. Sure. All right.
Oh, did it not go on that first one?
Mm-mm.
Might be a bug in the code. Let me check on that. Okay, so this one, is it going okay?
Kind of.
Does it take a longer delay?
It seems like it.
I'm gonna have to double check this one. Well, you know what? We're gonna look at this code.
Yeah, maybe you'll figure it out while we're looking at it.
See what I did wrong on this one. The one thing I know we did here is it should be pretty similar. We did break some of that out into functions. Just again to kind of show you how functions work, to sort of put blocks of code off and be able to call them from different places. So again, this time this is more similar to the first example, but we're setting our LED on, we set our pull pin, and the first thing we do is we say call reset the count, which sets it to 0. And that would be the same as setting that value here, but we're doing it there in case we want to call it anywhere else. And we don't in this code, but we'll be looking at some other code where...
You do.
Right
sorry,
there,
we do. The if.
Right. It's been a long day. I'm like, I know we call it there. There's some other code we'll be getting into where usually when you power up the MicroBit, it runs the on start. But sometimes you want to reset those values. So often we'll write code where pressing like button A or B will like run that reset. So if you want to restart something without rebooting the MicroBit, you can have a reset routine. So that's what we've got there. And then we call our display count, which again just shows the number. That's all it does. And then our forever, again, looks pretty similar to what we saw before. It's going to check if that pin is pulled low. If you press the button, it'll change the value. And so I think this part's interesting, the while loop. And this might be what's causing the issue.
Because it's if I do a decent press, I think is a decent press, it doesn't count it. It has to be a little bit held down a little longer for it to count it.
So we know the MicroBit runs slower because of the display, and that might actually be what's causing that here. And you'll see a weird part here in this while loop where it has pause. You're pausing 0 milliseconds. Sometimes this is done because having like nothing in there looks weird and confuses people. While this is happening, do nothing if there's nothing there. So sometimes people put in like a pause 0 or delay 0 just because it's still going to loop. It's going to go again as fast as it can, but because of our slowness with the matrix, it may be, running so slow that it's not catching what it needs to in here. But basically we're looking for like looping here until the pin goes high again. So until you release it. So that's what we're doing. So here we're looking for the pin to be, or the button to be pressed, the pin pulled low, and then it's going to go here and loop around until you let go, and then that's just going to change to a 1, and it's going to break out of that while loop. So, and then again, if it's gonna check if it's greater than 9. If so, it'll do a reset. If not, it'll just display it. So this code, in my mind, everything logically makes sense. How it runs on the MicroBit is a little weird. I might actually run this code. I may test it without the LED matrix and see if it works around that weird issue we just saw. And I think I thought I saw an issue when I did the video of that one, but I thought it was only on that first press. So I'm going to play with this one. There may be some weirdness in there, but again, it's kind of showing you some concepts. It does mostly work.
For the most part.
But again, it kind of shows how you can have different code that does the same thing or very close to the same thing. And look completely different. Yeah.
All right, and then our last one is, I believe, a countdown, right?
I think we have a comment here. Oh, we've got almost missed the Mike.
Oh, Mike.
Yes, you don't want to.
Welcome back, Mike.
Red pill, blue pill, all that stuff. All right, Mike's here. Okay, on to number 4. This one, we're just going to do something
Completely
boring,
different.
boring and interesting all at once. All right, 5, 4, 3, 2. Well, Mike, I hope you're timing this because, okay.
Mike would be the one to time it.
I know, right? So, again, same thing there. Let's look at our code. And you know what? I did add some notes about that in that part. Mm-hmm. So, again, this looks so simple. We're going to turn on the LED. We're going to set our pin. We're going to check if that pin gets pressed. And then we're going to set our values in here just for the heck of it. So our start value, 5. We counted down from 5 when you press that button. Mm-hmm. Our end value is 0. Set our current value to the start value, so it's going to set it to 5. Mm-hmm. And then it's going to loop. And what's that delay? 1,000 milliseconds equals 1 second, right?
It should.
It does. It does. But, oh wait, Mike's got more for us. I got to find... This kind of triggers me. Oh, well, that's interesting. I'm wondering why Mike would say.
I know, you might have to share more, Mike.
Okay, so it should loop through here, pausing 1 second between showing that number and changing the number. And when it's all done, it gets to 0, and then it pauses for 2 seconds and clears the screen. So if you press it again, starts at 5. So those of you good with time, like I'm sure Mike is, will notice that it's not 1 second between the numbers changing. It's a little more. Mm-hmm. I think I timed it out, and what did I say?
Of course you did.
It was about 8.5 seconds. So a little weird.
Does that include the 2 second pause, though?
No, because that happens outside the loop. So that's just to go like...
But it's still
probably,
the 0.
It's probably more. Like when I pressed 5, or when I pressed start and it was on 5, I started a stopwatch and stopped it as soon as it hit 0.
Okay.
Which should be 5, or worst case 6 if my math is all wrong. Right. No, it was more like 9-ish, but 8.5 was my, let's see, stupid millis. Yes. So there you go. Thank you, Mike. So there's a bit of a delay, as we've seen, in displaying that matrix.
Right.
The matrix is the matrix. I keep saying the matrix. It's kind of a cool trick. So if you remember, there's certain pins we can't use when we're using the matrix because those pins are used by the matrix. And the matrix is this, this grid thing. Mm-hmm. So as I understand it, instead of, Mike's got more. Phone number is the same. Probably. So yeah, anything displayed on the matrix probably just takes a bit more time. Mm-hmm. And Mike can probably help me here, but I assume the matrix probably does like a scanning thing, just like you would do with a matrix for input. Maybe that's what increases the time, but it does slow things down a bit. So again, if you're going to do a timer, now if we change this to what's 1,000 versus 600, what is it, like 400? If we change this to 400 milliseconds, maybe that would actually count accurately then. That's something for you folks at home to try. And maybe I
think it's definitely a good challenge for students in the classroom, though, to figure out how can I make it accurate.
Yeah,
absolutely.
If it's possible. If it is always a set sort of 6, and it would make sense. It's like a set thing. It's not like some random thing that changes.
Now, if we hooked up a 7-segment display instead and did basically the same thing, would it have that same delay?
No, it's all about the matrix. Yeah.
Got it.
Yes, and we'll be seeing that in the coming weeks, of course.
Months. Oh,
Mike's
well, you're gone for a little while.
It is hard-coded delay in the show. There you go. Forget to pause. Oh, interesting. That is interesting. Huh. So, Mike, I'm thinking you could probably write a library that works around that issue, huh? I'm going to wait for him to reply. But yeah, that does make sense. It kind of makes sense. It's one of those things where, for people like me or maybe Mike, where you expect something to work a certain way, and you're like, oh, I know I need to pause, or like it'll disappear before I can see it. it's kind of like how we add resistors.
Right?
to our LEDs. It's that stuff.
That's
like,
exactly what I thought of.
you don't think the normal common people would think about. So you kind of like try to do it to protect them from themselves.
Right.
And in doing so, it's like, you confuse the people who know too much, which, I'm used to in my life. So.
There you go.
Mike's got more. Hold on.
Yeah.
But controlling it individually by plotting them? Or how are you controlling them individually? Because we did we do plotting, or did I just do that?
We did
plotting.
plotting.
We did do plotting.
Yeah.
I've written so much code lately, I can't remember. Interesting. So maybe because we're doing show number or something. Yeah, so the plotting, that's interesting. I don't know. Man, let's see the big one there. See that large one? That's all Arduino code running.
There you go.
I wonder how fast I can get that stuff to run. I'm sure I can run extremely fast.
Probably.
Yeah.
We haven't even shown Mike the enormous.
He hasn't seen the
MicroBit.
large.
No.
Yeah, maybe
He's
next
only seen
week.
the large.
Maybe next week, since we're taking a little break after next week, we'll bust that out for him to see.
There we go. I like it.
But that is the code. Thanks a lot, Mike, for pitching in here.
Yeah, absolutely.
Explaining a few things. I'm gonna investigate, and we are doing 2 buttons next week. So what we'll do is I'll look at some of the things Mike said, and maybe we'll incorporate some changes for next time.
Awesome. I love it. Yeah, so next Tuesday we are doing a paper flower.
Yeah.
Next Wednesday we have a new project that I literally finished yesterday. It is a game spinner. And then Thursday we will be working with the LED matrix again for MicroBit University, but with 2 buttons.
Yeah. Well, it's funny that Mike brings that up, and I brought up the whole fact. Like I'm trying to do things that aren't so complex that are confusing and scare people away. But yeah, and that's why I think sometimes programmers write these sort of things that are, well, the whole idea of programming is to sort of take all this difficult stuff and build libraries around it to make it simpler. So
Right.
That makes sense that they would do that. But again, for someone like me, I'm like, why does it work this way? But
I'm telling you,
so
that's
good.
exactly what this is. We've had teachers reach out. They're like, this shouldn't work this way. Why is it?
Yeah, we've simplified
Yep.
paper circuits to the point where, and you know what, we explain it somewhat, but we don't go overboard explaining it, I guess, too.
But the average teacher, like me, in the classroom,
Yeah.
has no idea.
Yeah, if you just
So it
want
helps me
to
out.
light something up, like,
Right.
it's all good.
Yeah. Awesome. That is all we've got for you today. Don't forget to follow us on our social media platforms. You can find us on Facebook, Instagram, Twitter, X, and YouTube. The guides for all the MicroBit University stuff are all on browndoggadgets.com. And then if you have any questions, you can email us at help@browndoggadgets.com. And don't forget, if you want to go through some of these things with us and more, you can sign up for the Pathfinder Summer Institute, our circuitry and robotics with Lego and MicroBit. And you can do that at p2url.com/Pathfinders.
You got it.
We hope you enjoyed. We hope to see you next week.
All right.
Have a great weekend.
Thanks for watching. Please visit browndoggadgets.com for parts, projects, and curriculum. Follow us on social media @browndoggadgets. We'll see you next time.